Okay, let me attract your attention. So, should we go over this brief mm, discussion of the comments? So I think the images are frozen, so we need to speak or type answers, and probably let me suggest to go first with comments to Aaron's conclusions. So Kevin, would you like to start the discussion and share, like, focus the attention to any parts of Aaron's conclusions? Either system is not working or Kevin doesn't have comments. Fatima? Will your microphone work?
Okay. I think so.
Okay. Would you like to focus attention of Aaron on some aspects? I see there are several comments, so maybe you can bring some of them to attention of Aaron. Maybe he may elect to answer them immediately.
Yeah. I just wrote some general questions, comments like for non-technical audience, there is no, I don't see any message for non-technical audience who does not understand it, who is not familiar with this research, cannot understand anything, I think. And that's one thing. And there is nothing mentioned about applications of this research output and which community will be benefited from this research. That's all. Okay.
Thank you, Fatima. Aaron, would you like to give quick answers?
It is a work in progress, and it's not clear yet.
Okay. So, research community, do you have any specific researcher who may benefit, specific experimental group that may benefit of this computations? Like John Asbury with femtosecond infrared spectroscopy?
Well, if my hypothesis is true, that if when these are photo excited, it acts sort of as a catalyst to promote surface catch. And so if you can use a photon to push ligands off the surface, you will still have a charge on the surface, which could be used as a catalyst for some other type of chemical event, or even to do ligand exchange.
Okay. Yeah, very interesting. Thank you for answering, and thank you, Fatima, for bringing up this question. I also had a thought about it, but maybe it is a wrong one. our original idea was that trap states will be dark, and then this computation would be a mechanistic explanation of photodegradation, of how through cycling of excitation and de-excitation, quantum dots become darker, stop being light emitters. But you are telling that this states that you call traps are still bright, so maybe it is not as pronounced. You yes.
Point as well.
Oh, okay. Yulun, would you like to bring up to focus attention of Aaron onto your questions?
What is about entry barrier? And did you use the transition state search? Otherwise, can you find the activation barrier?
So I haven't done either yet, but just from molecular dynamics simulations, it seems that this hypothesis could be true.
Okay, in this case, maybe you need to be careful with your words, because when you say barrier, sometimes people just assume you are doing transition states.
Right. So this is more of just an outline of what to explore further based on what I have now. So I don't claim to have a transition state. Right.
And also, you mentioned some, I guess a few sentences later, you talk about deprotonation. How can you be so sure that it is a proton being transferred instead of a radical, or just anything else, I guess?
So I haven't looked at formal charges on the ions yet, but just from chemical intuition, I guess. Like in acetate. Not acetate, but I mean, if a carboxyl group has a hydrogen with it, it's not going to be charged. And then the other functional group is an amine, which isn't typically charged either. So it's more just from general chemical background, making an assumption.
Makes sense.
Yep. Many thanks to Yvonne for questions and to Aaron for the answers. I think it's very healthy development. Let me share some of my comments, which so I'm not sure that photodegradation is a good title. Maybe what Aaron is suggesting, photocatalysis, can be inserted there. Here is maybe I partially address what Fatima is asking for non-technical audience, that electron and hole do not interact but to each other, but induce distortion of lattice. I think it is maximal that what can be added for the non-technical audience. And there was a word which could be either my lack of vocabulary or it was a typo. I don't know whether it's fluctuation or some Shakespeare word that I'm not aware of. It
should be flocculation.
Okay. Okay. Yep.
So pushing.
Okay. Good. Yeah. Thank you. I'm enriching my vocabulary now. If this anion-cation complex was an original precursor, one may mention it. If it is not, then it is okay. So here, I do not know whether it's a gray area, but you are telling that upon heating, the pair of anion and cation leaves, and I'm trying to understand if there are two versions of the lowest excitation. One maybe at lower temperatures when this anion-cation pair is still intact, and another at high temperature when this anion-cation pair is departed. So would it be right to think that first, I do not know if it is only process of transition and if it is allowed to speak about these two configurations. Maybe there is only one, and second one is a transitional state. But if these two configurations are available, would it be correct to say that they have different pattern of lattice rearrangement? Not in the sense of ligand, but in the sense of bromines and leads, because if there is a charged trap and it is excited trap, it may induce more changes in the vicinity of this trap. Can you please comment on that?
So I guess if there was a trap, if you have a negative charge localized on the lead, which is positive, the surrounding, or what surrounds it are anions, so it should push them away. So that would be this, like what I would look for. I was trying to measure that.
Okay.
And I think for your comments, I think due to just the heating from the ligands moving, like time step 0, it has a trap state. Just because it pushed, or one of the ligands moved far enough away to have the negative charge on the surface right away. So to this point, there's not a continuous or along like the molecular dynamics like simulation, there's not a clear transition from both the charges being inside the box and eventually transitions to the negative, one of them being on the surface.
Okay. Yeah, thank you. And I have a big temptation to use the word photodegradation when it is appropriate and not appropriate. But you may decide whether results are sufficiently proving use of this word. It just would be hype, attracting attention of experimental audience if this work contributes to understanding of photo degradation, but if not, we may not use it. So in the last sentence, you are telling that the traps or quasi-traps are not dark. And how does it? How one can interpret it in the light of your earlier presentation today? If computer power will be sufficient to rerun this lowest state in this Bethe-Salpeter equation, would the trap become more darker trap or brighter trap with this conclusion that it still has non-zero oscillator strength sustain if one applies different methodology? Can you please comment?
I guess my intuition is that it wouldn't change very drastically. Like it might become slightly brighter, redshifted slightly.
Okay, so qualitative conclusion will stay the same.
Yeah, because I guess, I mean, what an exciton calculation would include that what we already don't have is Coulomb interaction, which I don't think would change. Like that might give a slight redshift, because since it's on the surface, they wouldn't interact as much. So I don't know. That's my best answer.
Okay, yeah, thank you. Are there more questions to Aaron on this conclusions? If no, let's go to the next subject, and I suggest we focus on the work by Yulun. So since it was PDF rather than Word, I do not see comments in the Google Drive. Let's double check. But maybe there were some comments made on local computers or by handwriting. Does anyone has suggestions and comments to Yulun's draft? Kevin, do you have some comments, or you pass this opportunity? Okay, it sounds Kevin doesn't have comments. Fatima, do you have any comments and suggestions to Yulun's work?
No.
Okay, thank you. Aaron, would you like to give some suggestions to Yulun? Maybe you made some comments, or maybe based on presentation of Nathan Walker yesterday, by observing analogy, would you like to give some constructive suggestions?
Well, I guess connection to Nathan's talk didn't occur to me. But I guess one question I had was, you had a statement somewhere talking about resonance phonon frequencies and their impact on the non-radiative rates.
Okay, I probably will not. Okay, I found.
Yes, right here.
Yes, yes, I found this place. So, Aaron, and what is your question to this sentence, to this logical statement?
Well, it's logical. It is logical. I was just wondering if there were plans for normal mode analysis, or whether you were just rationalizing how the simulations work. Because just as a reader, when I read that, it made me wonder, like, I wonder what the normal modes are.
Mm-hmm. Makes sense.
Okay, Aaron, can you please share your experience in the following? So, in the last paper by Aaron, or one of his papers, he computed everything as we traditionally do in the group, but then he used this argument about resonance with normal modes, and to support it he computed normal modes not for his biggest model, but he reduced it, like used thin film instead of quantum dot. Aaron, can you share your experience how expensive this calculation is? Is it something that one can do on a short notice, or it will be a major computational expense?
I think for the system Yulin actually uses, you could run it in a day.
So, can you tell how many atoms your system had and how many days it took?
I don't know atom count, but it's basically the same as Yulin's. It's a slab with ligands on top and bottom.
Mm-hmm.
His might actually have less atoms.
Mm-hmm.
So it's the same size. And for time, I think it was like 20 hours. Like, it ran in one like compute cycle.
Uh-huh.
Mm-hmm.
So I have a technical questions in a continuation of this discussion. The molecular dynamics can be stopped at any time and then continued by picking up quant car. Is it possible to do the similar trick with normal modes, or if the job is failed in the middle, one needs to restart it from the beginning?
I think it has to complete its run. Like, it doesn't compute time steps in the way that, like, molecular dynamics does.
So, it is important to count available hours in the job duration so it completes.
Right.
So what it does, it takes equilibrium and then shifts atoms into two directions away from equilibrium, and does it totally 2n plus 1, or n is number of degrees of freedom, like if number of atoms 6n plus 1, and then after this calculation is completed, it diagonalizes the force matrix, but approximate duration is equivalent to molecular dynamics with so many steps. Would Aaron agree with this?
Yes.
Okay. Do you have more comments or constructive suggestions?
Not at the moment.
Okay. Yeah. Thank you. Let me check if I had anything specific to add myself. One can speculate on this energy cannot be dissipated into single mode, and one can tell that the on-the-fly couplings accommodate do have non-linear nature and can accept multiple like dissipate energy of one electronic transitions into several nuclear modes. And such explanation is favorably taken by experimental community. It's not a suggestion for immediate completion. I just always had a curiosity if one would compute energies of orbitals through perturbation theory and make it as a continuous plot, like energy of orbitals as electric field. So instead of several points, it will be continuous line. Or maybe one can simply mention such an opportunity. Here, I wouldn't call it solar cell. It is, yes, it is solar cell, but it is too ambitious statement. I would put it in more gentle way. So like it's interface of material relevant to solar cell architecture. These orbitals are absolutely cool. They make like biggest sense of the figure, and it helps to interpretation to a major extent. I do not know if orbitals look similar way or they're different under electric field. Do you have, may I ask if you have comment on how shapes of orbitals change under electric field?
I guess for the initial conditions we explored in this work, the orbital shift is basically the same. So I guess there is some very little variation for the case in which the negative electric field is applied. But I guess for the non-field and also positive field, the orbital shape is basically the same.
But let me reformulate once again. Electric field, and you are writing it in the your concluding statement. Electric field has two consequences. First, it changes energies of orbitals, and second, it changes shapes of orbitals. So how big is change of the shapes of orbitals? Like if we redo this panels, HOMO minus 7, HOMO minus 1, HOMO minus 4, LUMO and HOMO, with positive or negative electric field, will the figures be different for human eye, or the changes in the orbital shape will be negligible?
You can say it.
You can. Okay.
Change to the orbit.
Okay. Is it easy to describe? Is there some regularity so they are pushed away from perovskite, or they come a little closer, redistribute into this.
I guess I need to double check.
Okay, so it is not, I do not think it is mandatory, but it could be an option to repeat these images and put it in supplemental information, or just verbally describe what is going on, because it could be very nature or curiosity of the reviewer. Okay, I think I'm done. Are there more questions to Yulun? If no, let's go to the next work by. Let me suggest we get to the work by Kevin. Just a second. Fatima, would you like to start to set up questions to Kevin, or maybe highlight most important of them?
I wrote some questions, but I don't see them now.
Pardon me?
It says that a newer version has been uploaded. So I wrote some questions, but I don't see them now.
So what I'm showing on the screen doesn't reflect your questions?
No.
Huh.
Only few, not all of them.
Okay, but can you select maybe those that are not shown? Maybe you can verbally.
Yeah, now I can see. So I can see there is an equation in the abstract. I believe it is abstract in the first page.
So you
I think it's it should be removed from the abstract, because there is and explanation of symbols also here. My suggestion is to remove this one from abstract.
So remove equations, symbols, and references from abstract. Make it plain text. Okay.
Yes.
Okay. Let's go further. Which page? Is there a specific page you suggest me to go?
Yeah, I think. And in figure, every time I can see this balance band. Balance is like this typo.
Okay, yeah.
And in figure, it shows that it says that convection band, balance band, but see which figure it is. Figure 11. It shows that it says that the conduction band, note the probability appears higher at the conduction band, but it's not. It's not written that it is which one is conduction band and which one is balance band. but someone can assume that the left one is the conduction band and the right one is valence band, as the probability appears highest in the left band.
Oh, so it is not properly labeled.
Yeah.
Okay. Any other place I should go to?
Yeah, I have other comments.
But is there something that it's better to discuss now, and maybe when you want to hear the answer of Kevin?
No, I don't think so. I just wrote the comments, not questions.
Okay.
If you can address those.
Okay. Yeah. Many thanks. Many thanks.
Yeah, and I don't know why I don't see all of my comments. Yeah, probably we can see.
They should be, and Kevin, if you hear it, please consider to maybe download this Google Docs document to your laptop right away, and when downloading it should include all this comments, and then you have it saved on your local computer. Yeah, thank you much, Fatima. Oh, Kevin, you didn't include here the. Oh, you did. Yes, you did. Excellent. Aaron, would you like to share your comments to Kevin's work?
I provided a couple.
Okay.
I guess the one that I would bring attention to is that in the introduction somewhere,
Uh-huh.
it talks about the mechanism of charge transfer.
Mm-hmm.
I think the example he uses is radiative, or using a photon.
Mm-hmm.
And then my comment was just other ways that, or other mechanisms like a phonon that could produce charge transfer as well.
Okay. So the charge transfer can be induced by excitations either by photon or by phonon.
Mm-hmm.
Good. Yes. Thank you. Any other spot in the document?
No, I think that was my main comment.
Okay. Yeah. Many thanks. Many thanks. Yulun, would you like to share some comments to Kevin's work?
Yes, I guess first my overall impression is this is like a thesis or lecture instead of a scientific paper.
Mm-hmm.
I guess for a paper you need to be concise and also be accurate.
Mm-hmm.
So I guess maybe majority of the introduction is not necessary.
Mm-hmm. So you are highlighting the fragments of a text that could be erased by your opinion.
Yes.
Okay.
And also, I guess maybe lots of information can just be transferred to support information.
Excellent, excellent. I like this comment. Kevin, if you hear it, do you are you aware of the concept of supporting information? Maybe microphone is not working, but feel free to ask anyone in the group about this concept, because it is a standard practice in scientific papers. Sometimes one accumulates some interesting data that are reasonable, and it's not like I do not want to discard them, but they do not fit into short and concise narration of the main text, and then they can be shown in so-called supporting information document. Please think about it and prepare to practice it. Yulun, would you please continue?
So I guess he has a very large figure, multiple panel figures for green figure and blue figure. I guess maybe he can just transfer these two figures to supporting information, but we'll keep one of them in the main text and just focus on this single figure.
So what you are telling is to take only one representative example, for example, HOMO -11 to LUMO 14 at 300 Kelvin, and show it here, and the rest of the table can be moved into supporting information.
Yes.
Okay. I think it would be much easier to read for reviewer, and the same thing can be done for the blue figures. Okay. Yep, makes sense. Any other suggestions or constructive criticism?
That's all I have.
Okay. Yep. Many thanks. Does anyone want to share comments on Fatima's paper right now? So I believe we gave a good round of comments last time, and there is still work on implementing those. So I think if Fatima doesn't object, we will conclude this today's session. Is it okay?
Yes, that's fine.
Okay, thank you so much. So if please consider to implement the changes, and it is just a possibility, a suggestion that the steps that Aaron introduced at the beginning of the meeting, we all may want to try to run. At least I have a curiosity to try to reproduce these things, because as time passes by, on one hand, we do need to satisfy our own scientific curiosity and target precision, and on the other hand, reviewers will be tougher and tougher each year, and they may want to for competitive papers to use last cutting edge. So picking up this skill is useful for all of us. So I think next week we still have a meeting, and in 2 weeks I'm not sure if group meeting will be available, but I'll double check. But on the May 14th, Thursday, May 14th, 11 a.m., there will be final exam, presentations of computational chemistry class, and you all are invited to join and maybe to ask questions. And on Thursday, May 7th, there will be review of student works, written reports. So you also all are invited to come and serve as editors and reviewers if your schedule allows. Of course, we are on this remote connection, social distancing, but I think it would be possible to practice reviewing in the same way as we do for the group meeting. So there is total 8 students in the class, and some of their works could attract attention, and some of them are your acquaintances and colleagues, like Aaron is probably acquainted with Salim Thomas. Fatima is probably acquainted with Amir Zhaofan and Yang Chao, and you will have seen all of them by substituting me on instruction. So they will present their works done primarily in VASP, and if your schedule allows, the attendance and help will be appreciated. So Aaron told that Pacific Chem abstracts are postponed to May 15th. So if you haven't submitted, there is still time. Are there any other questions to bring up right now? If no,
yes, I'll say that.
Yes, please.
May 7th.
7th?
That's when my yes. At 1. That's when my comprehensive exam is scheduled.
Is it open to the general public?
I guess so. I didn't see any restrictions.
So would you please share Zoom or whatever link to the group members?
Yes.
Okay, thank you. And if you are busy preparing it, then you have a good excuse not to review students' works. But if you will be 100% ready and you'll have nothing to do to calm you down before your own presentation, you're welcome to show up. It's optional, but of course your exam is a priority, like 2 orders of magnitude.
Do we need to practice?
Good idea. Yes. Let's. Aaron, what do you think?
That works.
Okay. Super. Okay. Anything else to discuss together? If no, then everyone is welcome to depart, and I'll stay online to answer questions, if any, for some time.